So the next one is you need to be able to analyze the stress strain curve and modulus of elasticity. Basically, you want to explain, and you need to be able to analyze which part is elastic region, plastic region. So stress strain diagram, which is very closely related to steel. Stress strain diagram indicates the behavior of material under load, which deform the behavior of material under load. The stress strain diagram can be given for compression, tension, or shear. So the data used to lay out the diagram are obtained from testing standard material specimen in a universal testing machine. So the strain values are laid out on the horizontal axis and the stress on the vertical. So stress, as we have seen before. So here is another form of a stress strain diagram. So at the bottom you have strain, which is unitless or inches in inches. And the vertical axis is stress, which can be pound per square inch or newton per millimeter square. So in empirical, in metric system, you have newton per millimeter square. So what I want to show you, actually what is important is the region, which is elastic strain and plastic deformation. So an increase in stress will produce a proportionate increase in strain up to the elastic limit. The elastic limit is the highest stress that can be imposed on a material without permanent deformation, and this produces a straight line on the diagram from 0 to elastic limit stress value. So basically, elastic limit here is elastic strain is the amount that you can impose on the steel material or other material of that tile without permanent deformation. So once you remove the load, the material will return back to its original position, to its original zero strain. So this indicated by elastic limit. So at the yield strength, the which is beyond the elastic strain, the steel will, or any ductile material, will not return back to its original zero strain, but rather having a permanent deformation. So this is what we always check during our PAT204. We check the buckling of column, either the allowed stress capacity before buckling is lower or higher than the yield strength. If it is higher than the yield strength, then yield strength is the cap, the limit. Although the column will not buckle at higher stress, but it will yield at yield strength. So that is a definition, because once the column buckle, once the column yield beyond once the column being imposed with stresses beyond the yield strength, the column will deform permanently, which in turn change the eccentricity, the moment of inertia of the column, which will also cause buckling. So the next one is modulus of elasticity. This is the proportional constant between stress and strain, the constant, which is the slope of this graph here, the straight line here. So for stresses within the elastic range, so this elastic range, any stresses along here, E equals stress divided by strain. So basically the slope of this line. The modulus of elasticity is a measure of stiffness and rigidity. So basically it's a measure of stiffness and rigidity. Having higher E, or modulus of elasticity, is an indication of higher stiffness or higher rigidity. as stiffness is the strength of concrete to resist any deformation. So having higher stress, having higher E will indicate the larger elastic strain, the larger overall toughness here, and also in turn indicates the larger stiffness. So for beams, E indicates they are resistant to deflections. So for beams, the E indicates they are resistant to deflection. Having higher E, which can indicates and can be an indication to a stronger strength carrying capacity. So steel has high E value, which is around 200 gigapascal, which is used structurally to carry loads with minimal deflections. So the last one, explain the advantages and disadvantages of steel as a structural material. So advantages, as mentioned previously, steel is lightweight, so lower dead load imposed on foundation, suitable for mobility. So for drilling rig, transmission tower, because it has lower dead load, so you don't need larger foundation to carry the steel structure. Low weight to strength ratio, you can spend longer between support, so especially in beam structure. So as steel has low weight but also has higher modulus of elasticity, as we mentioned earlier, high E value, so you can have high strength carrying capacity, but you won't have any large dead load due to the lightweight of steel. And the third one, steel has high ductility, so excellent for member to resist deflection, and also can be formed into various shapes for aesthetical purposes. And you can, as you've seen before, so it can be rolled, it can be cold rolled, depends on your design. But the disadvantage is it may require additional support to resist uplift force if it is being used for roof structure, as opposed, as you can compare between the steel roof structure, as we've seen before in many houses or bus station. As you can see, the steel roof, steel girders to support the roof, steel frame, steel trusses to support the roof, as opposed if you use a concrete structure, RC roof, flat roof, then you need to oppose the uplift forces compared to RC structure. To oppose the uplift forces due to wind, you can have the dead load is enough to counteract the uplift forces. So the lightweight maybe can be the at disadvantage on certain structure. And also the disadvantage is that the production of various uncommon shape is limited to factory only, as opposed to concrete that can be cast into shape at site. Although they can be formed into various shape, but it depends on the factory. As factory produce a most common shape that being used in the industry, as I mentioned before, for welded fabric, wired fabric, as at the largest sizes that is not produced at factory. So you need to you need to tie up yourself. So your design is limited based on the market availability. Any uncommon shape to be produced depends on the availability of the factory, or you need to have your own factory to produce that uncommon shape, which is costly. And also steel is vulnerable to corrosion, which requires corrosion protection. Either you have that cathodic protection, or you have painting, or you use steel alloys. And also steel have low durability towards weathering, which requires addition of chromium or copper. You need to you need to protect from acid attacks from weathering. So alloying is one of the method. As opposed to concrete, you just cast. That's why you have reinforced concrete. So the concrete acts as the protection from weathering for the steel which is embedded inside the concrete. And also steel perform badly in fires, and during, if you have a fire catastrophic event, or fire mishap in the structure, in the residential building. So the yield strength is being reduced by approximately 70% at 550 degrees Celsius. So if you have a steel bridges having a fire beneath it, so the steel might yield, might deform due to strong fire. So as opposed to concrete, which has stronger stronger durability towards fire, so steel may be at disadvantage in fire cases. And also steel has larger lateral movement at the seismic event of wind loading, and the seismic event or wind loading due to its high ductility. So as we mentioned earlier, steel has high ductility as opposed to concrete that is very rigid. So lateral movement during seismic load or during wind loading may cause cracking, because damages may cause damages in cladding of the overall building, and also may cause column shortening in terms of structure. So when the structure being displaced too much, and the column is not aligned due to lateral movement of steel, due to lateral movement, so the building may collapse due to column shortening. So these are all the disadvantages and advantages which you can derive from the mechanical properties of steel. So this video will be linked in your e-learning lab. You can watch later. An example of a question should differentiate between cold rolled section and reinforcing bars of structural steel. As I mentioned earlier, cold rolled section is a thin plate where you roll into your specified section, but reinforcing bars is cast into rib bars of certain diameters with 12-meter length. So that's the difference how it is made. Next one is how can it be used it can be used. Cold rolled section can be used directly, but reinforcing bars need to be embedded into concrete. And also cold rolled section has three different forms, which is differ in the section shape of the section, but reinforcing bars is basically circular sections with varied diameters. And also a type of example of question is that what is the advantage of using steel? As we know, low weight, high ductility, and also speed. We can expedite the construction duration because it's a prefabricated process. We don't need to wait for the things to be cast compared to concrete, which is need to let the concrete achieve its strength of 7 days or 14 days or 28 days. Steel can be used directly with no setting time. So you need to derive from the point, you need to derive further to explain in depth of the advantages of using steel as such a member. So guys, that's all. Thank you for listening.